Welcome to the 54th episode of Rising Tide. This is David Helvarg, and my co-host is Vicki Nichols-Goldstein of the Inland Ocean Coalition.
Hello, everyone.
And today we're also joined by our producer, Blue Frontier's Natasha Benjamin.
Oh, hi, David.
Hi.
Vicki.
Hi. Natasha, turns out, got her start in marine conservation as a student of today's guest, marine biologist Les Kaufman. Les, who's worked out of Boston University for decades, has a wide range of expertise, including in marine and freshwater fish, corals, evolutionary ecology, and more. On a very practical level, he studies human interactions with natural systems. Les has worked in the reefs of Florida, Belize, the Caribbean, also the waters of Palau in the Pacific, also Lake Victoria in Africa, the world's third largest freshwater habitat. So, Les, with so many possible topics, let's start with where you grew up and how you first connected to the sea.
Oh, hi, everybody. I grew up in the most unlikely place for a marine biologist, New York. And my first encounter with the sea was when a family friend marooned me on the beach somewhere out in the water so we could go chase girls. I was about 5 years old. And when he came back, he swore that I had gone a mile down the beach and I had stood bolt still the entire time. In fact, the tide was coming in and I was getting very nervous. So it was traumatic. And the rest of my life has been trying to overcome that trauma.
And how have you done that, Les?
Immersion therapy.
Into the blue.
Into the blue.
So when did you get organized about it in terms of your schooling and teaching?
Well, when I was 12, I started a bar mitzvah band. And my other three colleagues had tropical fish. So, of course, I had to have tropical fish. And that became obsessive, like everything else I've ever done, and led quickly to smuggling a saltwater aquarium into the basement against my parents' orders. And it just deepened very quickly after that. We used to go down to Canal Street in Manhattan to see the aquarium stock company, which was run by one of my colleagues' fathers. And that's how I was first exposed to all of the animals I study now, but as aquarium pets. And then in college, I took scuba diving. And in 1974, made my first warm water dive in Florida after spending years selling tropical fish in pet stores. And when I jumped in the water, there were beautiful rock beauties and queen angels, and all I could see were their prices hanging on their sides.
Well, how old were you when you were looking at those prices of those fish?
Well, I was, let's see, I guess about 21.
So you didn't have a big income at the time.
I didn't have any income at the time. Well, I had walking around money. I used to teach astronomy at Johns Hopkins, where I went for my whole schooling. And that gave me enough money to cover dive gear and stuff like that.
And Billy Causey, who ran the Florida National Marine Sanctuary for years, before that he was a tropical fish collector. So were you tempted?
Well, I actually, I used to go down to Beach 9 Street in Far Rockaway to catch tropical waifs that blow up in the fall, and I'd sell them to make a little more money. We'd get butterfly fish and triggerfish, and actually Billy was instrumental in the development of my career because after he was head of the sanctuary in Florida, I was able to hire him away for a while to help me rape and pillage when we were studying the gut microflora of rock beauty angelfish to figure out why they were so hard to keep in aquariums. It was
Wow.
really fun to watch Billy at work.
I love Billy. That's so neat that you've worked with him.
Yeah, I've stuck with Florida the whole time. Most recently, we had a project in Biscayne Bay, and currently I'm working with the Coral Restoration Foundation and the Coral Restoration Consortium on Mission Iconic Reefs, which is an attempt to learn how to restore coral reefs under adverse conditions in Florida.
So before we get ahead of ourselves, you're like in your early 20s diving, collecting fish in Florida. how do you get to be the sort of broad-based ocean ecology researcher and professor you are today?
Well, when I was looking for colleges to go to, I was attracted to Johns Hopkins because the college handbook lied and said that if you go to Hopkins, you could do whatever you want. And the translation was, if you go to Hopkins, you're a pre-med student. And so when I got there, I rebelled violently as a freshman, began not doing well in my courses, and instead I spent all my time bird watching, living in the woods on nuts and berries, running the observatory, and playing lacrosse. And that was probably the most important developmental step in my career. And then years later,
Wait, lacrosse is the most
oh,
important thing?
lacrosse is very important.
Oh, okay. Just wanted to
Yeah,
clarify.
no, crease attack. No, what happened was I was developing as a naturalist, largely on my own. I had a mentor in the bio department, a couple of them, that were very influential, Bob Ballantyne and Michael Beer. And then I realized that there was no organismal biology in the bio department, like no ecology, behavior, evolution. That was all over in the geology department, which was called Earth and Planetary Sciences. So I went over there, and this guy, Jeremy Jackson, told me that if I would quit this riff I was on and get my act together, I'd be in Jamaica in 1 year. And he was good for his word. I passed my classes. I was in Jamaica.
Good old Jeremy.
Yeah.
Who's a previous guest on the show.
Ah, yeah.
Yes.
He's a hoot.
And so you went down to Jamaica, and that's when you started doing your marine
Coral reef
ecology
work.
studies?
Yeah, in earnest. That year, that was 1974. That year, the Organization of Tropical Studies, best known for their work in Costa Rica, uh, held a course in Jamaica celebrating the Discovery Bay Marine Lab, one of the pioneer marine labs studying coral reefs, founded by Thomas Garreau. And Jeremy was one of the first generation folks working in there. And there was just an all star cast of professors. And we had this very intensive course. And that got me going. And it's also where I met Walter Adey, a scientist from the Smithsonian, who dared me to come cruising with him in the Eastern Caribbean so he could prove that there were no fish on reefs dominated by algae instead of coral. And actually, as it turns out, they were loaded with fish, but they were the color of the algae. And that began to set me off on research about why coral reefs don't always remain coral reefs. Sometimes the coral dies and it's replaced by seaweed. And that's a process that we're actually seeing writ large today.
And what is causing that process?
Well, it's a combination of factors. Coral reefs require nutrient poor, very clear water. Um, and they kind of, it's like a rainforest. They create a lot of their own productivity and sequester it in the reef. And one of the things that allows hard corals to grow, of course, they're animals. They have symbiotic plants in their tissues, microscopic algae, and that enables them to produce these hard skeletons. But they can't grow as quickly as the soft, supple seaweeds that can also live there. So, unless those seaweeds are grazed down, they can take over and kill the coral. So when you eat all the, for example, parrotfish and surgeonfish, or if anything happens to the sea urchins, the invertebrates that also graze algae, seaweed can overwhelm the coral. And that's how that happens.
And Natasha, I wanted to jump in. Um,
Uh-oh.
how how do you know Les? What is your relationship?
Les and I go way back.
Tell us about it.
um, so when I decided to study marine biology, I ended up at Boston University, and Les was my professor. Um, and at BU at the time, and I still believe that you still have this program now, we got to spend a semester at Woods Hole studying purely marine science classes. And I'll never forget, I was trying to remember, what was most memorable from my time there. And I think the thing that sticks with me most is taking ichthyology with Les and having to boil fish heads and reconstruct the fish head skeletons, and the stench of boiling a fish head for 6 hours in our, there was probably six of us doing it at the time, was one of the many fond memories of my time at Woods Hole, and working with Les and working with all of the students. It was definitely a moment in time that I won't forget, and I'm fortunate enough to have crossed paths with Les throughout my career in marine conservation, um, and excited to be here today with Les to talk about how far we've come. I was diving in the Florida Keys is kind of how I started. My dad took me diving in the Keys as soon as I could swim. And those were the days where there were big groupers and staghorn corals. And I kept going back every year and watching the groupers get smaller and eventually disappear, and watching all the fish get smaller and smaller and algae taking over those reefs. And that's when I knew I wanted to, continue to do this work. So, Les has been instrumental in trying to understand what's happened to those coral reefs. And I want to hear more from Les on the work that you're doing there to bring those corals back.
Wait. First, I want to hear if you still make your students boil fish heads.
Well, actually, Tasha, I think that may have been Professor Lobel. I think that your experiences with me may have been repressed.
Now I want to hear more about that.
I know that, yes, I
I
think the
took you out on the
theology
demo.
class was Lobel, and
Yeah,
you would take us snorkeling in,
yeah,
and seining for fish,
right.
in Woods Hole, and um,
You went
also
snorkeling
just
in the
you would
eel
make it
pond?
in the
Yeah,
exactly.
Eel Pond and MBO Beach and Nobsca Point. Yeah, Phil Lobel is into dead stuff, and I'm into live stuff.
We would go through the woods
Right.
and look at everything and find mushrooms and
Yeah. Well, I think it's really important to resurrect the idea that biologists should have naturalist chops. And the natural unit of function in nature is not the land or the ocean or the river. It's the integration of those elements organized into watersheds and ocean basins. So that's what I was trying to drive home to you guys.
So you've been working on coral reefs for, if I count it right, almost 50 years.
I'm sorry you said that.
Uh, we're all, what do we say, more experienced. And in terms of your experience, we're hearing that half the world's coral reefs, tropical coral reefs, have died in the last 50 years. I mean, what have you seen, and what's driving the change that we're seeing on the reefs?
I had always dreamt of being able to see evolution in real time. That was my dream, and that's why I wound up working in Lake Victoria. But mostly what I've seen is devolution, the collapse of ecosystems, changes in ecosystems, really profound change brought about by human activities. So when I began diving in Florida on that fateful day in 1974, the Florida coral reefs were actually aesthetically the equal of anything anywhere in the world, which is really unusual because they're at very high latitude. You don't expect to see such healthy reefs there. And since that time, I've been to and worked in Florida at least once a year, except for a while when I was ill. And what I've seen is like, I mean, the negative side of it is it's like a disaster movie. The positive side is that by watching mass extinction in its various flavors, we actually learned a great deal about how these systems are put together, and gain insight into how to facilitate their self reassembly, how to bring them back. We can't build them like you build a building, but we can help foster the pieces coming back together. So, what's going on in South Florida, for example, which is typical of what's happening everywhere in the world now, is that there's a combination of the watersheds being devastated and polluted and global climate change. And that combination, with the slight addition of us extracting enormous amounts of biomass from the ocean in the form of fish, in the form of building materials, all those things together leave little leeway for the natural system to repair itself. So in Florida, the whole hydrology of the state was changed so that enormous amounts of waste from agriculture pour into Lake Okeechobee and then are shunted directly to the east coast and the west coast of Florida, where they nutrify coastal waters, causing algal blooms, cutting off sunlight, killing the seagrass, which this year is killing a lot of the manatees, and degrading the marine environment. Much of that water flows south and used to be cleansed by the Everglades. But the Everglades has been horribly reduced and the water channeled into these canals. So there's very little opportunity for the waste to be stripped from the water polished, as we say. In addition to that, for many years, Florida was heavily overfished. Now there are more stringent fishery regulations, and much of the fish biomass, especially those critical parrotfish and surgeonfish, have come back. But now we're dealing with climate change, and its angry stepchildren, coral disease. We pour pathogens into coastal waters. We alter the environment and disrupt the natural microbial community of the corals. This weakens them, and this makes them that much more vulnerable to climate change. For example, when the waters in Florida or anywhere in the world where there are coral reefs become unnaturally warm due to warming, it makes the corals more susceptible to pathogens, including microbes that may even be normal symbionts of the corals, but under these warm conditions change in character and can become pathogenic. It's just like when your gut microflora is disturbed. Right now, we are seeing a plague sweep through the entire West Atlantic. It's a disease. We don't yet understand it. It's called stony coral tissue loss disease. And this disease, which affects more than 21 species of reef-building corals, has now brought the coral cover of the Florida reefs, which used to be on the order of 50% or more, they had declined to about 7%, 4 to 7% due to these collective insults. And now with this disease, they've fallen below 1%. So we've assumed this challenge under leadership with NOAA, the federal agency, to pool all of our academic resources, all of our practical knowledge, and just see if against this headwind, it's possible to trigger the reassembly of coral reef habitat.
So you're really talking about a cascading series of disasters of overfishing, nutrient, other forms of pollution, loss of habitat, and on top of all of that, the impacts of climate change. And in Florida, you're seeing all four of those. You work in other places like Palau and the Pacific where and I was just diving in French Polynesia, where you take out the other insults and you just leave climate warming in the ocean. And you see some impacts, but overall you still see healthy habitat. And how's your feeling of the survival of those reefs in the face of warming?
There are still many spectacularly diverse and healthy coral reefs. But if you look at climate change alone, it has two effects that ultimately take their toll. The first is the water getting warm. which can be associated with disease even very far from human habitation. And the second is the pH of the water becoming more acidic, which makes it very difficult for corals to repair or grow their skeletons. As a result, many of the most beautiful reefs in the world that still remain are hanging by a thread. They're on tenterhooks. The next time there's what we call a mass bleaching event, the water getting very warm, the corals losing their symbiotic algae and dying, it'll be very hard for the reef to recover. It's not the death of the reef that's the problem. It's the difficulty recovering. So what we're seeing now, even in the Indo-Pacific, are reefs that suffer a disturbance and then have difficulty recovering.
So another area you work in is kind of the relationship of human behaviors and natural systems, and maybe talk about if you're hopeful at that end.
There's a classic science fiction book called Foundation by Isaac Asimov that is now a TV series. And in it, there's a hero, Harry Seldon, who's a mathematician, who learns how to predict, not exactly, but the possibilities of what will happen to society as a result of emergent human behavior, as a result of the psychology of the masses. And he uses this mathematics to predict that the galaxy, which is an entire empire in this world, will have a dark ages 30,000 years long. And the question is, what can you do? What can you nudge to guide history away from the guardrails to minimize the time of this dark ages? I was very, very inspired by that story. And years later, I inherited a modeling team, an ecological modeling team called MINDS, the Multi-Scale Integrated Model of Ecosystem Services. An ecosystem service is all the good things we get from nature, the things nature provide us and that we often assume come for free. Nothing is for free. Anyway, when I got this modeling team, I thought, we can do what Harry Seldon did. We can create visions of the future, possible futures, mathematically, based on ecological theory, that if you show this to people, they'll automatically do the right thing. Okay, that was a little bit naive. So I went a step further into the abyss. I thought, maybe Harry Seldon was right, and we can actually predict human behavior. At that point, my wife said that if I didn't stop this, she was going to check me in. And we've since found that the human side of the equation really is very, very challenging. But there are two things you can do. Get the ecology straight, and then build curiosity, knowledge, trust, optimism about the future, and people will find a way to implement the right things to do. That may sound rosy-eyed, but it's the only solution I can offer.
And I think with many of us who are working with college students, young children, people who want to be activists and scientists, I do feel like we have to be optimistic. I mean, we're all in the ocean field and we can't give up now. So I think that's a very important thing to remember, to maintain our optimism and to keep moving forward.
Some of the issues we're seeing in the ocean are also freshwater environmental issues, and you've worked for years on Lake Victoria, the third largest lake in the world in Eastern Africa. Maybe you could talk to us how you got involved there and what you do there.
Sure. By the way, I dismiss the Caspian Sea as a lake and consider Lake Victoria the second largest lake in the world, David.
Ooh. You're getting controversial.
No. Yeah, Lake Victoria is one of the great lakes of East Africa and one of the largest lakes in the world. It's after Lake Superior, the largest inland freshwater body. And it's remarkable for several reasons. One, of course, is that this is where our species began, on the shores of that lake. Or it wasn't a lake at the time. It's alternately been a wooded savanna with lions running around on the what became the lake bottom, or a shallow lake. And the last time the lake dried up was only about 14,500 years ago. The remarkable thing is that on the very place that had been bone dry, when people were walking around in Africa, I mean, this is recent, 500 to 600 species evolved in the last 12 or so thousand years. From two ancestors, one coming from the north, one coming from the west. And while we were watching these animals, we could see genetic changes in gene frequency, in other words, evolution, happening before our eyes. So this seemed like the Galapagos magnified many times over. So I was fascinated with the system. But as is often the case, when I began work there in 1989, I was focused on abstruse evolutionary questions. Meanwhile, there was all kinds of human suffering around me. And one of the things that happened during that time is that the ecology of the lake began to change profoundly. It changed from a lake that supported a species of tilapia, like you buy in the supermarket. Well, the most delicious tilapia in the world lived basically just in Lake Victoria and a few surrounding puddles. That fish depended on an environment that was no more, that disappeared sometime in the late 70s, early 80s. And it was also heavily overfished, and it became almost extinct in the lake. At the same time, a very large predator, native to other parts of Africa, was brought into the lake by British colonists, and it just exploded in abundance. It's called the Nile perch. So a combination of the ecology of the lake changing, in other words, the limnology changing, so that this clear water, well-oxygenated lake became hypoxic or almost without oxygen in its bottom waters, at the same time that the surface waters turned from clear to pea soup with massive algal blooms. And hundreds of species vanished in about a 5-year period, about the same time it took for Nile perch to become 80% of the fish biomass in the lake.
And what drive the
Formerly,
ecological change, the hypoxia and the
well,
muddiness?
we're still not certain, David, but I'm pretty confident that climate change had a major role in it. When I began working in Africa, just about the time that the bottom of the lake lost much of its oxygen, that happened to coincide with the winds of East Africa changing. And the strong winds that used to blow the surface waters of the lake away, bringing bottom waters up, we call that turning over. And it's something that happens seasonally in most lakes. That stopped. And that allowed chemicals to build up in the surface waters that inhibited turning over, and dead algae falling to the bottom of the lake used up the oxygen. The bacteria that feed on it used up the oxygen, and we created a massive dead zone.
Within that area, I've seen a lot of photos and have spoken to people. There's also been a tremendous amount of plant growth.
Yes, water hyacinth.
Yes, which has made it really almost impossible in some cases to just maneuver around in that lake.
That's right. In
Can you
fact,
talk about that?
yeah, well, when you add nutrients to the water, any plant in the water can benefit and begin to grow profusely. I remember in 1992, I was out in the middle of Lake Victoria, and I saw a water hyacinth float by. Water hyacinth is a South American water plant that is notorious for invading areas where it's introduced and spreading very quickly and covering the whole surface of the water. The moment I saw that plant, that one plant, I felt like throwing up. I knew what was going to happen. And within just a few years, the situation you described had taken place. Enclosed bays in Lake Victoria became so thick with water hyacinth that people couldn't even draw water. They couldn't get their boats out onto the lake, the open water of the lake, to fish. It caused enormous hardship. And that was the most visible ill in Lake Victoria. We were lucky in that we were able to convince the World Bank to create an $88 million fund to figure out what to do about all of these problems in Lake Victoria. And we spurred the creation of a regional fishery organization. Here, I had hoped it would be an environmental organization, but there's a lot of turf battles, but at least something focused on fisheries and the condition of the lake. And that has since matured. It's called the Lake Victoria Fishery Organization, and the science that's been done by African scientists with colleagues from elsewhere in the world has been instrumental in maintaining productivity in the lake and supply of fish and availability of livelihoods. But Lake Victoria is still changing and reeling. The amazing thing is that it's still viable, just different. And it's a testament to the incredible ingenuity of nature, the incredible resilience. And think about it. It's actually hard to make a species go extinct, although we have learned to be very good at it. It's actually hard to utterly destroy an ecosystem, although we've become very good at pushing them back into dark corners. The hope is there for them to come back, not exactly as they were before, but in a form that preserves nature's bounty and diversity and helps support human life.
So when you went there, you were studying the animals, as you said, the fish that were doing evolution in real time that made it the Galapagos of fresh water. Is that still happening in the lake, or is it more a question of basic survival now?
Well, first of all, the Galapagos are the Lake Victoria of the ocean. It's just a faint shadow of what's going on in Lake Victoria. But in fact, over the last few years, we've had a grant from the National Science Foundation. I have a close colleague, other than my African colleagues, I have a colleague in Switzerland named Ole Seehausen, who's a leading evolutionary biologist. Ole has taken up the task of leading work on the genetics and genomic evolution of these fishes, and I've taken up the trophic ecology, how the community works and who eats who. And one of the interesting things that we've observed is that there's a particular species of fish we were looking for that has the odd habit of smashing snails in its mouth. And this fish, we thought had gone extinct in the lake. And we became very excited when we began seeing it in enormous numbers. But when Ole analyzed the genetics of the fish we were seeing now, it wasn't the same fish. It had the head of the thing we were looking for and the tail of something else. What had happened is that two not very closely related lineages had hybridized to produce something new. Ole ultimately discovered that the trigger for the explosive production of these hundreds of species was a hybridization event much longer ago between fishes from the Congo Basin and fishes from the Nile Basin. So what we learned is that, quite contrary to the conventional thinking in evolutionary biology up until that time, hybridization can occur and can be a tremendously creative force in evolution. Now, actually, the plant biologists have known this for a very long time. So we have seen new species appear before our eyes.
I think this gives us some hope that this is not just about mass extinction and ecosystems collapsing, but that ecosystems are resilient in their own way and will adapt. Whether or not they will go back to what we once knew is probably, is not going to happen, but we're seeing this all over. We're seeing it in Lake Victoria. We're seeing it in coral reefs. We're seeing it here on the north coast of California, where the kelp forest ecosystem has completely changed. What is that going to look like in the future when you have urchin barrens and loss of kelp? And what I'm hearing and what I think is really important is giving us that sense of hope that things are changing, but there's this resiliency and change that's coming, and that you're seeing less in all of these different systems.
That's absolutely true, Tasha. We're trapped between hope and hubris. We have the nerve to think that we can destroy nature. I mean, that's laughable. What we do instead is force nature into a form that is dangerous and ugly to us. Nature doesn't care. It can assume a great variety of forms. The decision is ours whether we want it to be friendly toward our needs. I would like people to shift from the notion that we run the world to the biblical and indigenous notion that we are stewards of it. I mean, when you listen to Native Americans, for example, that's a common theme of Native American culture across the board. I mean, our colleagues in the tribes are humans exactly the same as us, so they don't always do the right thing, but they have a philosophy that tends to encourage the right thing happening. So I think this notion of stewardship is critical, and it shouldn't be thought of as a chore. It should be thought of as a joy. It's taking part in the creation of new life. And so that's a value. That's not something you teach like a scientific fact. That's something that has to be inculcated through families and through schooling. And then the third thing is perspective, is to understand how you can have what you can do to have the maximum magnifying effect. And that's going to be case specific. So in the case of the coastal ocean, I actually think that having your voice heard, participating in the political process, in North America at least, we have a attempt at a democracy. And that's an incredibly powerful instrument. So being more politically active and using this awareness and knowledge and putting it into play is what I would recommend. The rest of it is details, just like they say about the golden rule and the Torah.
So Les, I think that is a fantastic place to end our podcast. And I want to thank Natasha, David, Les for being here on the Rising Tide Ocean podcast. I think your perspective was just beautiful, and I'm so glad that you had a chance to share it with our listeners. And we really appreciate the time that you've taken to be with us today. So thank you very much.
Yeah, I really appreciate what you guys are doing. And Tasha, I am so proud of you.
Thank you.
Rising Tide is a production of Blue Frontier, co-hosted by David Helvarg and myself, Vicki Nichols-Goldstein, with support from Natasha Benjamin and Ellie Curlow. Rising Tide's editing services and additional technical support are provided by Studio Cape May. The theme song is written and performed by Ethan Kenbarg. You can find Rising Tide, the Ocean Podcast, at www.bluefront.org or download it from Apple, Google, Spotify, or wherever you get your favorite podcasts.
Off in the salty ocean, off where the waves roll free, the sparkling water rises, then crashes to the sea. Out amongst the breakers, you'll have no need to fear. It's true, it's the blue frontier. Off in the salty ocean, off to the blue frontier.
Sparky, come here, buddy. Sparky! There you are. Good boy, Sparky.